Okay, welcome back. Welcome back to another video with Teacher Dakers, of course. Our topic that I'll be looking at is scale factor. So that's our topic for tonight. Objective: to find the scale factor to compute actual lengths and areas from a scale drawing. So scale factor and scale drawing come hand in hand, alright? Before we start doing some calculation, I want to define some terms and so on. First one I want to look at is scale factor. It says in two similar geometric figures, the ratio of their corresponding sides are called the scale factor. Corresponding sides are called the scale factor, alright? A scale factor is the factor by which all the components of an object are multiplied in order to create a proportional enlargement or reduction. Enlargement meaning it gets bigger, or reduction meaning it gets smaller. Alright? Alright, so scale factors that are less than 1 represent a reduction. So scale factors that are less than 1, meaning if they're a fraction where the numerator is smaller than the denominator, we know that's a reduction, meaning that the new object that will be produced, or the image that will be produced, will be smaller than the original object. Examples: if you have 1/2 as a scale factor, you know that the new image that you will get will be smaller than the original one. 2/5, that's another example. 3/4, 1/7. So once it's a fraction where the numerator is smaller than the denominator, once it is less than 1, you know that scale factor is going to produce an image that is smaller than the original. But if the scale factor is greater than 1, it represents an enlargement, meaning that you'll get a bigger object or a bigger image. Alright? Example: 2, 10, 4/3. So this time you notice it's a fraction, but the numerator is larger than the denominator. Alright? So that will be greater than 1. When the numerator is larger than the denominator, we know that fraction is greater than 1. Alright, I have two objects here. Alright, I have this triangle and I have this triangle here. The length of this side is 5, the length of this side is 3, the length of this side is 6. If the scale factor is 2, meaning I'm going to multiply each of these sides by 2, it produces another triangle where the sides are double. Alright, so we multiply 5 by 2, we get 10. Multiply 3 by 2, we get 6. We multiply 6 by 2, we get 12. So once the scale factor is greater than 1, we're going to get a bigger image. Alright? But if we were going from the larger triangle to the smaller triangle, the scale factor will be less than 1. 1/2 is less than 1. So if we multiply each of these by 1/2, 10 multiplied by 1/2, that's going to give us 5. 6 multiplied by 1/2, that's going to give us 3. 12 multiplied by 1/2, that's going to give me 6. And notice these sides correspond. This side corresponds with this side corresponds with this side, and this side corresponds with this side. So meaning that those sides fall in the same position. Alright? Remember earlier we said that with the scale factor, the figures has to be similar. So figures have to be similar. How do we know when a figure is similar? The figures have to be the same shape. So you cannot have a triangle and you have a rectangle and said that you are trying to find the scale factor. You cannot do that because what? The shapes are different. So it has to be a triangle. Both of them would have to be a triangle. Both of them would have to be a rectangle. Both of them would have to be a trapezoid. Both of them would have to be a parallelogram. All right? It does not have to be the same size though. They are the same shape, but not the same size. So similar figures, one of the characteristics, it has to be the same shape, but it not the same size. That's one. The next thing about similar figures, corresponding angles are equal. So the angles that fall in the same position, they must be equal. For example, this angle and this angle, they would fall in the same position, so they are equal. This angle and this angle, they will fall in the same position, so they are also equal. All right? So corresponding angles, meaning the angles fall in the same position, they are equal. So if this angle here is 30, this angle is 30, not because one is small and one is large, all right? If this angle is 30, this angle is also 30. If this angle is 50, this angle is also 50. Right? So corresponding angles are always equal, not because they are not the same size, but the angles are equal. The next one says corresponding sides are proportional. What do I mean by corresponding sides are proportional? Just like here. If I had multiplied 2, 5 by 2, I get 10. If I had another number here, for example 4, if I multiply 4 by 2, I would get 8 here. That means they are not proportional because I'm not using the same scale factor. So they have to be using the same scale factor in order to produce the other image for it to be proportional. So proportional, once you're getting a different scale factor, they are not proportional. Right? So for similar figures, must be same shape but not the same size. Corresponding angles are equal and corresponding sides are proportional. Alright, let's look at 2 problem right here. We're finding x and y. Alright, so number 1, we're going to find y here and we're going to find x. Alright? It tells us that the scale factor from triangle A to triangle B is 1 to 2. So they give us the scale factor here, 1 to 2. What is the scale factor saying? This scale factor is saying B is twice A. So 1 to 2. 1 to 2. So if you double A, you get B. If you double A, you get B. Or A is half of B. Alright, so to find y would correspond with this side 12 inch here. Y correspond with 12 inch. Since B doubles A, to find y, we'd have to multiply 12 by 1/2 or we divide by 2 to get y. So we multiply 12 by 1/2 or we can divide by 2 to get y, which is going to be equal to 6. So y is equal to 6. How do we get y? Multiply 12 by the scale factor. Can change the whole number to a fraction. 12 times 1, that's going to give me 12. 1 times 2 is 2. 12 divided by 2 gives me 6. That's y. So y is equal to 6. That's what we know. Right? Now we are finding x. We want to find x. Remember the scale factor says B B doubles A. So 1 to 2. So B doubles A. So to move from A to B, we have to double. So we multiply 5 by 2, which equal to 10. X equal 10. Alright? So when given the scale factor, A to B, we are multiplying, and we multiply 5 by 2, that's how we get 10. Let's try number 2 here. It says scale factor of Q to P. Q to P. So this time we're going that direction. So Q to P is 1 to 3. 1 to 3. What is this saying? This is saying that P is 3 times Q. P is 3 times Q. That's what it is saying. It says Q to P, and you have to pay attention to the direction in which they say. So Q to P, we are going that direction this time around. The first one we were going this direction, now we are going this direction. So P is 3 times Q. Let's find X. If P is 3 times Q, to find X, we have to multiply the 4 here by 3. 4 times 3 will give us 12. So X is equal to 12. But if we are going, we want to find Y here. These two sides correspond. You also have to pay attention to the sides that correspond. These two sides here corresponds. So to get Y, you either have to divide by 3 or you multiply by 1/3. Is the same. So 9 divided by 3, that's going to give me 3. So Y is equal to 3. X equal 12, Y equal 3. Alright. This question says, what is the scale factor from triangle ABC, to triangle DEF? We want to find the scale factor from ABC to DEF. So we are going that direction, from the smaller to the larger. Just thinking about it, we are going from the smaller to the larger. Remember, we said that once you're going from smaller to larger, it's an enlargement. And what do we say about the scale factor? Once it's an enlargement, the scale factor is greater than 1. So we know that we must get a number greater than 1 in order to find the scale factor. Alright? Scale factor, I'm going to use SF for scale factor. Scale factor is always the new object over the old object. Alright, so it's new over old. Always the new over old. How do we identify which of the object is new and which of them is old? The object that we are going to is the new, because that's the one that we will be forming. And the one that we are coming from is the old. So in this case, this one here would be the old, this here one will be the new, because it says that we are going from triangle ABC. So the one that you're coming from is the old, the one that you're going to is the new. So that's the direction we're going. So this triangle will be the old, this one will be the new. So to find the scale factor, only thing you need to use corresponding sides. AB would correspond with DE. BC would correspond with EF. AC corresponds with DF. Corresponding sides, AB correspond with DE. BC corresponds with EF. AC corresponds with DF. Alright? So only thing you need to do is to take corresponding sides to find the scale factor. And I'm going to show you using all 3 sides the scale factor. So we said that ABC corresponds with DEF. So DEF would be the new. So we know DE will be the new. So DE would be on top. AB would be at the bottom. Those are the 2 sides that correspond. What's the length of DE? DE is 20. What's the length of AB? That's 10. We can simplify that fraction to find the scale factor. 20 divided by 10, that's going to give us 2. So the scale factor here is 2. Any corresponding sides you use, you should end up back with the same result. Let's use EF. EF would be the new, so 12 would be on top. EF corresponds with BC, so 6 would be at the bottom. 12 divided by 6, still 2. Any corresponding side you use, you should end up back with the same number. If we use DF, that would be D 14. That corresponds with AC, which is 7. So 14 divided by 7 still give us 2. So the scale factor there would be 2. Scale factor would be 2. Alright, here I have another question. What is the scale factor from the large triangle to the small triangle? What's the scale factor from the large triangle to the small triangle? So, large to small, that's the direction we're going. If we have a large triangle and we end up forming a small triangle, we know that the scale factor is going to be what? Less than 1. It has to be less than 1 because we're going from the larger to the smaller. So we know that in our mind that our scale factor must be less than 1. If we're not getting a number less than 1, then it is not correct. Alright? Remember I said scale factor is equal to the new object over the old object. How do we identify the new? How do we identify the old? New is the one that we are going to form. That's the new, the one that we are going to. It tells us that the larger triangle to the smaller triangle. So we are moving from large to small. That means the small is the new and the large is the old. So from is the old, to is the new. Alright, so whichever one that we're going to form, that's going to be our new. Alright? Let's look at the corresponding sides. Let's identify the corresponding sides. 16 would correspond with 12. 8 would correspond with 6. 20 would correspond with 15. 16 with 12. 8 with 6. 20 with 15. So only thing you need to use is corresponding sides. So new is the smaller one. So if we are using these two sides, because these two sides correspond, 12 would be in our numerator, 16 would be in our denominator. Once the fraction that we get can be simplified, we must simplify the fraction. How can we simplify this fraction? We can find a number that can go into 12 without leaving a remainder, as well as 16 without leaving a remainder. So the number must be able to go into both numbers without leaving a remainder. And we can use 4. So we divide top number by 4, bottom number by 4. 12 divided by 4, that's going to give us 3. 16 divided by 4, that's going to give us 4. So the scale factor is 3/4. Scale factor is 3/4. Any corresponding sides we take should give us back the same result. Let's take 6 and 8. These are corresponding sides. 6 would be the new, that goes in the numerator. 8 would be the old, that goes in the denominator. If you look at this can simplify by using what? 2. Divide top number by 2, bottom number by 2. 6 divided by 2, that's going to give us 3. 8 divided by 2, that's going to give us 4. See? Same 3/4 we're getting back. Same 3/4. Use these two sides that correspond. I'm just showing you the example with all the sides. But in a test, or if you're solving in class, you just need to use one of the corresponding sides. Alright, but I'm proving to you that anyone you use, you should end up back with the same result unless it's not a similar figure. Alright, so here 15 would be in our numerator and 20 would be in our denominator. Find a number. Once a fraction can be simplified, we must simplify the fraction. So find a number that can go into the numerator as well as the denominator without leaving a remainder. And we could use 5. So divide top number and bottom number by 5. 15 divided by 5, that's 3. 20 divided by 5, that's 4. So scale factor is 3/4. Alright, let's continue. You can pause the video and try here to find the scale factor, alright? It says, what is the scale factor from A, B, C, D, that's this figure here, to M, N, O, P, that's this figure here. First thing, which one is coming from, which one it's going to. Identify which of your figure is old, which of your figure is new. It says that we are coming from A, B, C, D. So A, B, C, D is the old. Anyone you're coming from, that's the old figure. We are going to M, N, O, P. That's our new figure. So that's the direction in which we are going. Once we're moving from a large to a small, we know that our scale factor must be less than 1. We are moving from large to small, scale factor must be less than 1. What we said about the scale factor is equal to new object over the old object. All the thing you need to do is to take corresponding sides. I'm going to use these two sides, DC and PO. So PO, OP would be over CD. Alright? What is OP? OP is 4, CD is 6. And we can find a number to go into 4 and 6 without leaving a remainder, which is 2. So we divide top number and bottom number by 2. Numerator and denominator divide by 2. 4 divided by 2, that's 2. 6 divided by 2, that's going to give me 3. So any one of the corresponding sides you use, you should end up back with the same answer. You can try the other sides on your own, alright? Alright. With scale factor, we can also find the missing sides of objects. Alright? This question says, the two rectangles are scale drawings. What is the measure of x? So we can find x. To find x, we can find the scale factor. We can find the scale factor, new over old. Since this is a side missing, we'll consider this one to be the new and this one to be the old. Take corresponding side. We want to find x, so we could not use these two sides because we do not know the side, the length of this side. We know the length of these two sides, so we have to use the corresponding sides that we know to find the scale factor. New would be 28, old would be 7. 28 divided by 7 is 4. So the scale factor we know is 4, but we want to find the missing side. You could also say, what did I do to 7 to get 28? What can I do to 7 to get 28? I would have to multiply 7 by 4 to get 28. Anything I multiply this one by to get this side, we have to multiply this one also to get this side. So 5 times 4 would give me 20. So x is equal to 20. Alright, x is equal to 20. 7 times 4 will give me 28. Any number I multiply this one by to get this, I have to multiply since they are proportional by to get that one. Alright, we are going to try these two last one and then we'll stop there, alright? So we could look at it. Since this is the side we want to find the missing side. This is the side we want to find. You could ask yourself, what did I do since 8 and 24 correspond? What did I do to 24 to get 8? What did I do to 24 to get 8? I divide by 3. Alright, what did I do to 24 to get 8? I would have to divide by 3. What did I do to 18 to get 6? Also divide by 3. So to get this missing side, I'd have to divide 21 by 3, which gives me 7. This one would consider to be the new. This one would consider to be the old, because that's the side missing. Right? Other way we could do it, we could find the scale factor, new over old. New, find the scale factor. Say we're using these two sides. New would be 8, old would be 24. We can simplify this fraction by dividing by 8. You have to know your multiplication facts. 8 divided by 8 will give me 1. 24 divided by 8 will give me 3. So the scale factor here is 1/3. All you need to do to find this missing side is multiply 21 by the scale factor. Remember to change any whole number to a fraction. Put 1 over it. 21 times 1, that's going to give me 21. 1 times 3, that's going to give me 3. 21 divided by 3 equal to 7. Missing side, it is 7. You can pause the video, try this other one on your own. I'm going to do this last one. Alright, so let's continue. We're finding this missing side x here. The pair of figures is similar. Find the missing side. So we're finding x here. To find x, this would be the new, this would be the old, because we are moving from this one to this one to find the unknown. So anywhere the unknown is, that's going to be our new in this case. Since it didn't tell us from to R2, alright? So anyone the unknown is, we consider that one to be our new. Alright, we can also look. 10 and 40 would correspond. What can I do to 10 to get 40? Think about it. We'd have to multiply 10 by 4 to get 40. What did I do to 14 to get 56? Because these two sides correspond. I'd have to multiply 14 by 4 to get 56. Same here. So to get x, I have to multiply 3 by 4, which is going to give me 12. If we are not sure, can easily find scale factor. Scale factor is always the new over the old. 40, I'm going to use 40. 40 corresponds with 10, so 10 goes in the denominator. We can divide by 10. Divide by 10. Which will give me 40 divided by 10. Will give me 4. 10 divided by 10 will give me 1. Same thing as 4. So the scale factor is 4. Since I know my scale factor, all I need to do is to multiply. 3 times 4 give me 12. That's the end of this video. Remember to leave a comment and ensure you subscribe. Alright? Thank you for watching.